Hello everyone, welcome to my channel. In this video I'll be looking at applications of differential calculus, and to be specific I'll be looking at how to determine area bounded by two functions. Now to start with, we have question 1 here. It says determine the area bounded by the following functions, and f of x equals x squared minus x minus 6 and g of x equals x plus 2. So we're supposed to determine area bounded by these two functions. So we have two problems here. The first one is we have to sketch these two functions, and the second one is we need to determine what we call limits of integration. So let's see how we approach this one. Right, page 1. Our first question is, we're looking, if we have enough time we're going to look at question number 2, but our first question is f of x is equal to x squared minus x minus 6, and the second function is g of x is equal to x plus 2. Now we need to sketch these two functions. Now sketching of functions, perhaps I'll come with another video where I'll look at in details on how to sketch these functions, but the assumption is that at this stage one knows how to sketch the graph of a quadratic function and also a linear function. So I'll go ahead and sketch this. So our answer then will be as follows. We need to sketch this, like I said, the two functions. So here we go. Briefly, is our x-axis there, y-axis, and looking at this function here, obviously if you try to factorize it, you will see that it has, I'm talking about x-intercepts now, it has two x-intercepts. Check this out: x squared minus x minus 6, y equals this, and to determine x-intercept you have to equate this to 0, because on the x-axis y equals 0. Now factorizing this, you'll see that it actually is x minus 3 and then x plus 2, and this equals 0. So we have x minus 3 equals 0, and then x or x plus 2 equals 0. This gives us x equals 3 or x equals minus 2. So we know that it will have two intercepts on x-axis at minus 2 and 3. So I'm going to sketch it briefly like this, from minus 2 like this. So I'm basically saying at this point here we have minus 2 comma 0. Remember, on x-axis y 0, and at this point we have 3 comma 0. Those are the two values we got, if you remember here. Now this function here, g of x equals x plus 2, it will have, when y is 0, x equals minus 2, so it will pass through that, and when x equals 0, y will be equal to 2, it will pass through 2. So let me just extend this up a little bit because the intercept will be quite up there. So if I may use a ruler here now, not necessary, but yeah, just so that we spend less time, that would be the function g of x equals x plus 2. Let me just extend it down a little bit like that. Now remember, our point of interest is that point there and this point here. At least we know the what we call the limits of integration. Here we have x equals minus 2 starting from there, and what would be the value of x at that point going down there. So in order for us to determine these 2 points of intersection, which will give us limits of integration, we have to equate these two functions and solve them simultaneously. Now, how do we do that? Here is how we approach it. So I'm going to say here, limits of integration. Down here, limits of integration. You have to equate the two functions. So we're basically saying f of x equals g of x, because at these 2 points they have the same values of y. Now this means x squared minus x minus 6 must be equal to x plus 2. Right, writing this in standard form, we have x squared minus x minus 6 minus x minus 2 is equal to 0. taking us to page 2. We'll come back to this page. Rewriting that equation, we're basically saying we have x squared minus 2x minus 8, and that should be equal to 0. Notice here that the two x's are both negative, so we have minus 2x, and then minus 6 minus 2 is minus x minus 8. So that's what we have here. Factorizing this one, I'm going to be quick on this. This is x minus 4, and then we have x plus 2, and this should be equal to 0. Solving this, we're having x minus 4 equals 0, or x plus 2 equals 0. This will be x equals 4, or x equals minus 2. And this at x equals minus 2 is this point here. So that point there, basically we are saying if you come down here, the value of x there is going to be positive 4. That's what we're saying. From this, that's what we're saying. So now we have our limits of integration. So basically, we look at this function here. Is it integrable on the entire span or space from minus 2 to 4? And yes, this one is integrable on the entire interval from minus 2 up to 4. What about that one? Is also integrable. There is no 10 or sharp 10 from here up to there on both functions. They are both smooth. That one is smooth and that one is straight. And therefore, to determine area, this is the area we're interested in, that area. In order for us to determine that area, we're going to look at a small rectangle. A small rectangle, if I draw it here, this small rectangle has width dx, if you like, and the length of this rectangle is going to be the upper function minus the lower function. So we're going to sum up these rectangles from here all the way up to there. That introduces us to the idea of integration. So we're going to say, therefore, if A is the area, this shaded area here, so A is the area, shaded area, we're going to say A equals shaded area in this diagram here, and then we're going to say, therefore, our A is just going to be the integral. Remember, from x equals minus 2, x equals minus 2 there up to x equals 4. We solved it here, from x equals minus 2 up to x equals 4. X equals minus 2 up to x equals 4 of what? The upper function minus lower function. What is the upper function? Upper function is basically x plus, you can see it, x plus 2. That's the upper function. Lower function, that is the one. So we're basically saying upper function, g of x minus lower function, which is f of x. And then we're saying, so that will be our length and that will be our width. Now let's punch in the functions. So this will be equal to the integral from minus 2 to 4. What is g of x? Where g of x is x plus 2. Minus, what is f of x? Where it's x squared minus x minus 6. And then we have dx outside there. Expanding that and simplifying it, we have the integral from minus 2 up to 4 of x plus 2 minus x plus 6 dx. Putting that information, this is x squared, yes. Putting that information together nicely and cleaning it up, integral from minus 2 to 4 of what? Of minus x, let me start with that, squared, and then this will be plus 2x, and that will be plus 8 dx. Now, this is a very simple function to integrate. As you will see on page 3, I want to integrate this as quickly as I can. So we're going to say that is equal to, not implies that, is exactly equal to, so now we're integrating this function. Remember, we have to say x squared, we have to add 1, and then the result we divide. And then the x here has a power of 1. We add 1, it will be 2, we divide. And then this will be 8x, obviously. Right, so what we're having now is minus x cubed over 3 plus 2x squared over 2 plus 8x. And we're integrating this from minus 2 up to 4. Now notice this is what we have here. Now we simplify this part. So now I'm going to take it to my next step. And I have, let me start with positive terms, and then this will be at the end. So or I can just leave it the way it is, minus x cubed over 3, and then I'm going to say plus x squared, and then plus 8x. And we're saying we're evaluating this from minus 2 up to 4. So we punch in 4 then. Punching in 4, so what we have is now minus 4 cubed over 3 plus 4 squared plus 8 times 4, and then we're saying minus, open brackets, we take minus 2, put it there, so now we have minus, and then we have minus 2 cubed over 3, and then plus minus 2 squared, and then plus 8 times minus 2. Now simplifying this part, this is minus 64 over 3 plus 16 plus 32, and then we have minus, let's simplify this expression inside brackets first. So that is going to be minus 8. With this minus, it will be positive 8 over 3. So 8 over 3, and that will be positive 4, and that will be minus 16. And what do we have? We have minus 64 over 3, and then plus, this will be 48, minus 8 over 3, that is minus 12, so it will be plus 12 here. Now, so I'm going to take the positive terms. This is 48 plus 12 minus 64. Remember, they have this, they are base. Let me just write it the way it is. First of all, 64 over 3 minus 8 over 3. This one here is 60 minus, and here we can simply say, watch this, 64 plus 8 over 3. You have the same denominator. So this is 60 minus, and that will be 1272 over 3. This is 60 minus, if you divide 3 into 72, I think it's 24. And when you subtract 24 from 60, the answer is 36, and this is square units. That is the area bounded by the two functions. Remember our target, the question was determine the area bounded by the two functions. Applications of differential calculus, and like I said, to be specific, we're looking at how to determine area bounded by two functions. So this is our first one. Now I'm gonna look at the second one. If I'm too fast, please let me know in the comments section below. But I want to move now to example number 2 that I have here. My second example is I think I got it here. So much paper on my desk. Let me just check it. Example number 2. Too much paper on me. Let me just check here so that we spend less time. Example number 2. All right, I'm just gonna write it down because I wrote it somewhere on a nice page. Probably it's amongst these papers here. Example number 2. No. All right. I still feel I can find it. Just give me a minute. A lot of paper on my desk here. Here we go. Example number 2. There it is. We're supposed to determine area bounded by the function f of x equals x squared minus 6, and then g of x equals the minus the absolute value of x. Now I'm going to go straight into it because time usually on these matters can be a very serious factor. So number 2, we have f of x is equal to x squared minus 6, and then g of x this time is equal to minus the absolute value of x. Now I want to remind you on the definition of the absolute value before I proceed. Remember, step number 1 is to sketch the two functions. Sketching the two functions serves two purposes. One, determine the limits of integration. Number 2, it helps you to check whether the two functions are integrable on the interval or not. In a case where at some point they are not integrable, you have to cut or divide the area into two regions, and then you perform two integrations. Now this one here, it's exactly a typical case of what I'm saying. I wanna explain to you or remind you the idea behind the absolute value. Remember the definition of absolute value. We say the absolute value of x is equal to x if x is positive minus x if x is negative. That's the definition of the absolute value. And therefore, if I put a minus before this, therefore I'm going to say minus the absolute value of x should be equal to minus x if x is positive minus x. Remember, I'm just putting minus in front if x is negative. So basically, if I have a function y equals minus absolute value of x, I'm going to have that function will have two expressions. One expression, this will be y equals minus x, and that will be y equals x for x is less than 0. So let's just remind each other here that the line y equals x is basically this one. The line y equals minus x is this one here. But remember, the first part says when x is positive, we're interested in this part. So we're interested in this part when x is positive. And when x is negative, we're interested in this part. And therefore, our function, the function we're interested in, this absolute value, y equals minus absolute value of x, is basically that one. I erase that part, and I erase that part. Now, clearly, you can see that this function here is not integrable at x equals 0. That's why it's critical that you sketch these functions before you venture into finding area. So now, I'm going to be as quick as I can. Let me sketch. Step 1, we sketch the two functions. We've already done the sketching of the absolute value function. And I said that the absolute value function is basically this one here, this one here. But this one here, if you sketch it, it will have an turning point on the y-axis somewhere here, where it will be minus 0, minus 6, if you see what I mean. And therefore, I'm going to have to sketch it like this. Turning point there, like that. Just sketching. So the area we're interested in is this area here. That's the area bounded by the two functions. So remember, this is y equals minus x, obviously for x greater than 0. This one here is y equals x, obviously x is less than 0. And this one here, if you allow me to use y again, this is going to be y equals x squared minus 6. So now, first part done. I know I'm going to have to divide this function. That's y-axis and that's x-axis. I'm going to have to split it along the y-axis. It means I'm going to have to integrate it from this point to the point x equals 0, and then from here up to there, because that function is not integrable at x equals 0. Now, so how do I determine the points of intersection in order for me to work out the limits of integration, values of x at that point and that point? All I have to do is equate the two functions. Now, what am I saying? I'm saying f of x equals g of x. Now, remember, g of x has two functions or two expressions. So we're saying x squared minus 6 is equal to minus x. If you're interested in this part here, minus x, positive x, if you're interested in that part, because we're saying y equals x. For minus x, it will be your interest in that point there. So solving this will give us the two intercepts, that point, and the other one will be, obviously, if you extend that, it will tell you where this line should cut that function. But we're interested in that point. So we solve this equation then as follows. So what we have now to determine the limits, the upper limit of integration, we're saying x squared minus 6 equals, let me just copy the question, minus x. This gives us x squared minus, bring x to the left hand side, or add x on both sides, minus 6 equals 0. Factorizing this, it will be x plus 3, and then x minus 2 equals 0. Two solutions there, x plus 3 equals 0, or x minus 2 equals 0. This gives us x equals minus 3 or x is equal to positive 2. All right, so actually these 2 points of intersection are basically saying not extending that. That would be for this function, but I'm saying this function, if you extend it up here, it will cut this function at x equals minus 3 on the left hand side there. But we're not interested in that. So we know at least 2 values there we have. This will be 2 because that's the positive value. At this point here, x cannot be negative. It has to be positive. And we used y equals minus x, remember, there, in order to determine that point, the value of x at that point. So we're going to say that's our upper limit of integration. The lower limit of integration, we're coming back here and we're saying we want to find the coordinate value of x at this point. How do we do it? Y equals x equates to g of x, f of x, x squared minus 6. So we are now going to say, let me name these points here. This is A and that's B. So I'm going to say here now, this is at B, that one. And then I'm going to have x squared minus 6 equals x. Remember this part here? Solving this, x squared minus x minus 6 equals 0. Factorizing this, it is x minus 3 and then x plus 2 equals 0. So x minus 3 equals 0 or x plus 2 equals 0. This gives you x equals 3 or x equals minus 2. Again, it tells us that if we extend this, it will cut this function at x equals 3, but here we're interested in minus 2 there, which is this is at A, the lower limit of integration. So now we are fine now. For the two parts, we know the value of x there and there. And so we're going to say, looking at a small rectangle there, this rectangle has width dx, and length is going to be upper function minus lower function. That will be the length. So it's going to be upper function x minus lower function, it's x squared minus 6. And then on the other side, if we put a rectangle there, small rectangle also, that small rectangle will start from x equals 0 all the way up to that point, x equals 2. The width, it will be dx. The length is going to be the upper function, which is minus x. We're subtracting x squared minus 6 from it. All right, so taking us to page 6. Page 6, we're saying, therefore, if we let a be equal to area will be equal to the integral from minus 2 up to 0. Remember, from minus 2 up to 0, from x equals minus 2 up to 0 of the upper function, which is x, minus lower function, which is x squared minus 6, that one there. So we're now saying x minus x squared minus 6. Brackets are critical there. And then dx. But I have to add because I'm talking about the entire of that shaded area. On this side, I'm going to say the integral from 0 up to 2, from x equals 0 up to 2 of the upper function, which is minus x, minus the lower function, that part there, which is x squared minus 6. You can see it there, x squared minus 6. And then I have dx. Now, what I have to do is to simply integrate the two functions and evaluate them on these limits, and then I'm done. So this is going to be equal to, I'm going to start with the top one. The integral from minus 2 all the way to 0. Expand the brackets there. We have x minus x squared plus 6 dx plus the integral. We're here now, 0 up to 2. Expand that, it will be minus x squared plus 6 dx. Fantastic. Now, this is 2. Now, let's integrate that part. Let me stretch this back a bit. That will be x squared over 2 minus x cubed over 3 plus 6x. Hopefully you can catch what I'm trying to say. Power is 1, I add a 1 and then I divide the result. I add 1 to 2, I get 3 and then I divide. 6x, remember 6x, why it comes out to x, if I may be a little bit childish here, but to help those that cannot see it, remember 6, if I'm integrating 6, you can also write this as 6x power 0. But x power 0 is 1. 1 times 6 is 6. So we're saying you're adding 1 to the power. So add 1 to this number here, and then divide the same by the result. So this is why you have 6x over 1, which is just 6x. Right, hopefully you can see that. Right, let's carry on then. So we're now saying we're integrating from -2 up to 0, this part, remember, and then I'm going to say plus. That part there, if you're integrating that part, it's going to be minus x squared over 2, and then minus x squared over 3, x cubed over 3 actually. So this will be, I'm going to put the minus there, x cubed over 3, and then plus 6x. Limits of integration 0 up to 2. Right, let me put the minus there so that I don't forget. Fantastic. Now let's putting in 0, you can see the whole of this collapses. So this will be 0 minus, and then I'm going to say minus 2 in there. It's going to be minus 2 all squared over 2, then minus 2 all cubed over 3, plus 6 times minus 2. I'm closing that bracket there. I have to close this bracket here, if you like so. And then I have a plus sign here. Now this part here, substituting 2, we have minus 2 squared over 2, and then minus 2 cubed over 3, plus 6 times 2. And if you like, I can put this in brackets also. Minus 0, because if you punch 0 there, the whole thing collapses. Here, if you punch 0, the whole thing collapses like we started there. Now, let's clean up. So the first part, I'm going to say 0 minus, let me maintain that bracket. This is 4 divided by 2 is 2, and that's minus 8. And then with this minus, it will be positive 8 over 3, and that's going to be minus 12. I'm done with the first part. I'm coming down here, and I'm going to say there's a plus sign there, that plus sign. And then this part here is minus 2, and that part is going to be minus 8 over 3, and that will be plus 12. Right, so let me simplify this, taking me to page 7, and that should end the question, page 7. So what are we saying now? Let me move this one down a little bit. Right, so basically what I'm saying is, right, what I'm saying now is this part, the first part, will be equal to, remember, we can leave this one out now. It will be minus 2 minus 8 over 3 plus 12. Right here, the plus sign doesn't change any sign inside there, so it's going to be minus 2 minus 8 over 3 plus 12. Now let's put positive terms together. The 12 and the 12 will give you 24, and the 2 and the minus 2 minus 2 minus 2 is minus 4. And then here we have minus 8 over 3 minus 8 over 3. This is 20 minus, and that will be, if you like, 16 over 3, because they have the same denominator, so you can just add the numerators. And this is going to be multiplied by 3 here. It will be 60 over 3 minus 16 over 3, and this is actually, if you subtract 16 from 60 over 3, and the answer is just going to be equal to, I think, 44 over 3. Remember, we're supposed to say square units. This is area bounded by two functions. If I may remind you, our original functions, I put somewhere here. There you go. We're interested in area bounded by those two functions, and this is the area we've been determining by using integration. I am going to stop here in this video. This is almost 30 minutes now since I started. I definitely will have to come again with many examples on applications. We're starting with area. Hopefully we can move to volume at a later stage. We're starting with single variable calculus. We will move to multivariable calculus in terms of volume, right? Like I said at the beginning, if you're new to this channel, don't forget to subscribe, support us. Your feedback is greatly valued. Right, see you next time.